All right, let's get started. So good morning and welcome everyone. Welcome to our session, What's in Store for Energy Storage. My name is Frédéric Morancy. I'm the Vice President of Schneider Electric Services and Microgrid Solution. As you will see, we have an amazing group of innovative industry experts on our panel today. Let me introduce them to you. First, we've got Ramya Swaminathan, CEO of Malta. We've got Jen Fonger, Chair of the Energy Storage Canada and Vice President of Business Development and Distributed Resources at Ameresco Canada. We've got also Alex Rost, Manager, Resource Qualification at ISO New England. And we have Edward Arlitt, Supervisor of Advanced Technology Research, Independent Electricity System Operator. Today, as we lead the charge, we will, with the help of our panelists, we will dream of the next 10 years of energy storage. We'll touch other very important subjects such as sustainability, the impact of the electrification of transport, and grid system reliability. And we will finally look at the field of research and studies that are yet to be explored. As it has been said in the other session, a little bit of housekeeping here. If you want to interact with the panelists, please feel free to ask your question on the Q&A section on the right of the screen, and we will make sure that towards the end of our session, we'll open up for a Q&A section. Let's get started with the first question. As I said, we'll dream and we'll ask our panelists here, how do you see the next 10 years? And what are the barriers and the challenges that those opportunities will bring to the battery energy storage to come through? We'll start with Ramya. So what is your point of view on that?
Fred, thank you. Thank you for having me here, and thank you to all the conference organizers. I'm just delighted to be able to be here and share my thoughts with this audience. So I think we are at a remarkable time across the board in the energy space. So if I may just lay out a few things that I think are significant drivers of what is happening today, and then how they're going to play out so we can kind of peer into the future, as you said, look forward 10 years. So when we think about some of the most remarkable things that are happening globally in the energy electricity generation space, one of the most critical dynamics that's developing is that renewable energy is now the cheapest form of generation. We are seeing auctions for renewable generation, primarily in the solar space, clear at $10 or so the megawatt hour in a variety of auctions globally. And so if we were to generally kind of put a note on that, what we would say is that generally the cost of generation is asymptoting to zero. Essentially, the costs are coming down almost faster than we've predicted, than we've known what to do with. And that's just a remarkable fact. Now, what are the implications of that? You're seeing more renewables adoption, partly in some places because of climate change or sustainability concerns where governments have mandated that, but you're also seeing it simply for economic reasons, as I said, going back to the fact that it's the cheapest form of generation. Renewable energy is great from a sustainability perspective, but of course it carries with it some real implications for folks who operate grids and want to provide power on a resilient and reliable basis day in and day out to their customers. Renewable power is intermittent. We are seeing the effects of that intermittency by having real curtailment in certain places where there's a lot of renewable generation. And we're also seeing reliability and resiliency, and we have very esteemed colleagues here on the line who can certainly speak to that in the context of traded markets, but we're seeing impacts on resiliency and reliability kind of, again, across the globe. In addition to that, what we're also seeing is that fossil fuel assets are retiring globally. Primarily coal assets are retiring and not being replaced by other traditional fossil assets. That capacity is being replaced by renewables. And that also has implications for the way that we deliver power relative to load. And then finally, the last thing I'll say on this, and I think, Fred, it touches on one of the topics you want to cover today, is that we are seeing today, and I think we're going to continue to see, a significant increase in electrification as we electrify the transportation sector, as we electrify the building sector, et cetera. And so when you put all of these different factors together, what you get is a picture that is just rife with opportunity and challenges, of course. And so if I were to look forward and peer into my crystal ball, what I'd say is the next 10 years are going to present an unprecedented opportunity for us to, one, change the way we deliver and manage our electricity generation and storage and delivery system, but also specifically in the context of energy storage, I think we're going to see an unprecedented opportunity to take all these intermittent sources of power, to firm them, to time shift them, to use forms of electricity storage that provide the kind of ancillary services that traditionally are provided by fossil assets within the grid system, and really radically shift the way that we think about the makeup of our electricity sector. And I think you're going to see more and more penetration of electricity storage, particularly, and at the risk of sounding a little self-serving here, particularly long duration storage. As you may know, Malta Inc. is a company that's developing a long duration storage technology. And we think we're really on the brink of, as I said, unprecedented opportunity for market adoption in a variety of places.
Thank you, Ramya, for this statement here on your view of the future. So we'll listen to the other panelists as well, and certainly come back to you after. So Jim, what does this question and what you've heard from Ramya inspire you on your vision of the future?
Well, Ramya's done an awesome job at setting the stage for one of the reasons that energy storage has such a bright future moving forward. And you covered a lot of the basics in terms of why energy storage is moving forward. I mean, you did a great job on that. And I'd like to pick up from that. Also want to thank Frederick. Thank you for inviting me to be part of the panel today on behalf of first my employer, Ameresco Canada, who is very much into microgrids, as your company is, and helping customers decarbonize, but also on behalf of Energy Storage Canada, which represents over 60 companies in Canada that are part of the energy storage supply chain. And for anyone who is in the audience, if you're looking for reference materials, if you need any help or you're interested in some of the things that you're hearing today, please reach out to Jason Rangooni, who's our executive director, and he can help direct you to find some of that information. I think what I wanted to really define in terms of, and this builds on what Ramya was saying, is why is energy storage so important from the fact that it can actually deal with this intermittent renewable problem. And what I'm going to say is it's more of an opportunity, I think, than it is a problem once you get into energy storage. And really what's happened is previously with fossil resources, there has been a direct link between the fuel and when that resource operates. And in terms of looking at regulation, and I know regulation is used in many different ways in our industry, so just to define by what I mean by regulation, in terms of having that asset ramp up or ramp down in the previous paradigm, that's always been connected with the generation asset. And originally what happened is once you move into the intermittent concept between renewables and wind, that was looked at as a disadvantage, where in fact, now that energy storage is economic and can be placed on the system, you really have an advantage of taking resources when they're available, no matter what their fuel status is. You can take those resources when they're available and move them into points on the grid that are best used in periods of peak demand. So in other words, in Ontario, for instance, and Edward's very familiar with this, we have many times when wind has to be curtailed. These are our grid-connected wind resources. If we actually had energy storage inside load centers, all of that excess energy can be moved from the outside in terms of those grid-based, utility-based systems, can be moved inside load centers, which then can be used at periods of peak demand. That's a tremendous advantage. And in fact, one of the things that should result from this is transmission planning, distribution planning in terms of what's required in the way of poles and wires to actually facilitate how energy gets used at its greatest point is really an advantage that energy storage brings moving forward. So I think in terms of, what are the disadvantages or certainly the obstacles we have right now? Generally speaking, I think it's still out there that energy storage is expensive, and it's not. Much like the opinion is, or the perception is that renewables are expensive. And as Ramya so eloquently put out there, based on what's happening, renewables are not expensive, and in fact are the best way to move forward on generation. And looking at actually regulating or controlling the energy that comes out of those assets, energy storage can do so many things to make sure that that value is brought home at good price points for stakeholders. So the future is bright. There's some great new technologies that are on the horizon. The fact that the car companies now are almost all in, GM, Ford, Honda, and obviously Tesla, all of these companies now are all in on the energy storage side. With all that expertise coming forward and the price advantages that's going to bring, it's going to bring some huge opportunities for the industry.
Thanks, Jim, for this picture of a very bright future. And what I hear already from Ramya and you, Jim, is the world of possibility, which is around creating energy flexibility. So we'll turn now to Alex, and for everyone on the call today. And you see that Alex, we don't see his video. It's not that Alex is camera shy. It's just that we had the technical difficulty this morning, but we're very pleased to have Alex been able to make it. So Alex, what is this forward-looking picture, and what you heard already inspire you of the view of the future? And after that, we'll turn over to you, Edward.
Thanks, Fred, and sorry about not having my video. Maybe in the end, it's probably to everyone's benefit, but I think I don't really have much to say in terms of position than I have to supplement what's already been said, because I think Ramya and Jim have done a good job describing at a very high level the overall situation. Ramya talked about a shift to electrification, and I think this is going to happen more and more as societies seek to decarbonize. It's been very interesting in my career to see how much things have changed, let's say in the last 3 years than compared to the many years before. So this is a change that's happening, it's coming, and it's coming at an ever increasing pace. In ISO New England, I work with what's called the forward capacity market. In the forward capacity market in New England, we run an auction to procure capacity for a year-long period that starts about 3 years into the future. And so what's helpful about this is, number one, it helps incentivize investment in the grid, including new technologies, but it also acts to serve as a bit of a, let's say, canary in the coal mine, or a way to peer into the future of what's really coming. Because if you run the forward capacity market economically with the right pricing, then it should reflect both new technologies and the price of those technologies as you start to see people bring projects through the forward capacity market. So maybe to bring a little bit of data of what we're seeing, in the next 10 years, I see that we're going to see a lot more different technologies, and I think storage is going to be a piece of that. From about 2015, we have in New England 20 megawatts of large-scale grid connected, so transmission system connected, battery storage projects come online. So 20 megawatts since 2015. In our last FCA for the 2024-2025 period, so that would be June 2024 through the end of May 2025, we procured a decent amount of battery storage. For example, we procured 3 projects on the large scale size, totaling 575 megawatts in total. So these are projects that are expected to show up in 3 years. That's a big step change. I think the other thing we're going to see too, and we're already starting to see, is smaller scale projects that are popping up across the distribution system. Typically projects that are less than 5 megawatts is what we're seeing. And so in our last forward capacity auction, we did see about 30 projects less than 5 megawatts that involve storage participate. So, and these numbers again are increasing very quickly. Maybe one more thing to touch on that I think is going to continue to show an increase of projects like this is recently the federal regulator in the United States here implemented or put out FERC Order 2222, which is focused on making sure distributed energy resources can aggregate and fully participate in wholesale markets. So I think there's going to be a lot of interest in getting storage to participate, not just at a standalone storage facility, but at the co-located level with other technologies, and even things like aggregating electric vehicles and making that a resource to provide services to the grid.
Thank you, Alex. Thanks for your view. So, Edward, on your side, so several things has been said, but would like to hear as well from your crystal ball of the view of the future, what you see. So.
Great. Thanks very much, Frederick, for the opportunity to speak today. And, I think that the sentiment I've heard so far across my fellow three panelists is partly about this remarkable turning point in the industry. I think we're all seeing different facets of that right now. So before I look into the crystal ball, let me just take a brief moment to reflect on the past 10 or 11 years that our company's been involved on the energy storage file, beginning back in 2010 with our first offline laboratory experiments with a couple of energy storage providers to look at the possibilities of energy storage providing regulation service to the power grid, so intra-dispatch moderation of frequency and system balance. And for many of the system operators across the continent, that was sort of our starting point for energy storage. And at the time, of course, our other really big interest was renewable integration. And again, given the expense of storage 10 years ago, there were very few, if any, examples in North America could really point to say, well, here's where storage is actual practical example of where storage is being used to offset the variability of renewable power. So here we are a decade later, and you look at the collective build queues now across all of the system operators in North America. So that includes ISO New England, ISO Ontario, and 7 other system operators that preside over open electricity markets on the North American continent. And we now collectively have 168 gigawatts of hybrid storage facilities now proposed in our collective build queues as of the end of 2020. It's a number that's gone up by something like 30 or 40% just in the past year, even during the sharpest economic downturn in a generation. So I think all of that builds the case of us really getting to new territories. The long-standing storage promises of energy storage are now becoming viable economic propositions. I think that is really what makes this present moment different from our starting point 10 years ago. And all of us now, certainly in the system operator community, have all gone through system integration efforts. The ISO, we just instituted our first market rules for energy storage back in February of this year. That was a culmination of several years worth of work and effort and with our stakeholder community. And so I know Jim is well familiar with our efforts here, as I'm sure as a lot of the attendees here today. Here specifically in the province of Ontario, when we look now forward in terms of our crystal ball here for the province of Ontario, we are again, a remarkable moment for us, I think, coming up over the coming decade. What makes us a little bit different from other system operators in North America, we preside over a very large contracted portfolio of generation contracts on behalf of the Ontario government. And over the coming 10 to 20 years, we're approximately 21 gigawatts worth of contracted energy supply is going to be coming up for renewal at a time when we're also retiring a significant nuclear power station here in the province of Ontario and losing 3 gigawatts of supply over the coming decade as well. And so just to put that in perspective, 21 gigawatts, we're roughly going to hit 21 gigawatts about 5 o'clock this afternoon here on the Ontario power grid. So it's almost our entire peak demand supply. The supply base needed to meet our entire peak demand is going to be renewed over the coming decade. We're going to have a lot more to say about it, but we're certainly very mindful of what's happening in the build queues now, where hybrid storage facilities, standalone energy storage facilities, and renewable energy now has really now become the fastest growing segments of the electricity markets across North America. Certainly anywhere where you have organized, deregulated electricity markets, these are the predominant aspects. And I'll just, again, just one other stat just to throw out there, which I think gives a bit more insight also to what we're coming up for in the next 10 years, is the International Energy Agency just released their global renewable energy statistics that showed that 280 gigawatts of renewables were added, across the IE member organizations just last year. And again, worst economic downturn in a generation, and it was the largest stepwise increase in renewables since 1999. So again, it feels like for energy storage, there's a coiled spring, and I think what we'll get into in a moment here with the discussion panel in terms of the big challenge is how do we ensure that we're actually making the best possible use of assets, both at the wholesale market and distribution levels, and make sure that there's actually a healthy competition between those assets. Alex alluded to FERC Order 2222 happening in U.S. system operator jurisdictions. Even though we're not subject to FERC Order 2222, we're feeling a very similar pressure and imperative here in Ontario to make sure that we actually have cohesive competition at both levels of the system, wherever storage and other controllable assets are situated. I'm sure we'll get into that as our discussion goes on here.
Thank you very, very much, Edward. So probably as there's been already a good level of elements been put in perspective from each of the panelists. Is there a point that has been said that the panelists would like to react already? Or complement or challenge? Why not as well challenging, right? The perspective that has been said. So
absolutely. I think I just wanted to, I think both Alex and Edward really started laying the groundwork for this, and perhaps I can just follow up and sort of put a fine point on one of the things that we see as a barrier, a challenge on the as a countervailing force to all this remarkable opportunity in the market, and it's really about recognizing the value of long duration storage. And the point I'd make about that is obviously lithium ion and short duration energy storage is now commercially mature, it's technically mature, and it has the market acceptance, including on the commercial side, that is the revenue streams, to support the incorporation of that into renewable projects as standalone battery storage, et cetera. Where we do see a gap, a white space, and a real barrier is on the long duration side, where in our view, the need for long duration storage is evident, right? And I can give sort of some examples that probably crystallize it pretty clearly. If we're going to firm a diurnal cycle, where we have solar, for example, where the maximum irradiation is, call it 6 to 8 hours, and if you're trying to charge during that time and then really discharge or generate for the remainder of the day to serve a 24-hour cycle that is fully powered with solar, what you're really looking for is durations that cover the rest of the day, right? Call that 16, 18 hours. And one of the barriers to that happening, again, it's a global situation, is that although the need is evident, market design and the recognition of the value of long duration storage, which is partly what FERC Order 841 was about, is really not yet mature in a variety of markets. And that is ultimately going to be a really important economic parameter to iron out. In addition to that, some of the kind of values that have been traditionally provided by fossil assets for free, like rotational inertia in grid systems, are really not traded as separate revenue streams. They're not stripped out. Now, we're starting to see the development of that in the UK, for example, where there is a value placed on rotational inertia. And some grids need it more than others. The need is more dire in certain places than others. But I think what we are going to see is a real recognition of the fact that the original market design was very tailored to the generation assets in those markets. And we got not only electricity, but ancillary services provided by those assets in a way that need to be teased out and decoupled and valued separately.
Yeah, Fred, if I can add in, I'll take a little different perspective from the standpoint of, and certainly where Ameresco is going is helping its customers provide resiliency and reliability on site. Don't have to talk about what's happened in California in terms of the wildfires and what it's done to the electricity system there. I'm sure everybody on the panel and in the audience is fully aware of what's happening there, and also what happened recently in Texas. But the desire by customers to ensure, as we go through some of these climatic events, these other events that are going to happen because of the climate change that's happening around us, reliability on site is becoming a major desire and a major financial factor for customers looking at putting what they can on site in terms of their own energy generation resources, which really can take the current industry that we've got and turn it on its head in terms of how it's actually designed. And energy storage on site actually provides many opportunities for companies to do that, in addition to solar and other technologies that are going to come on board that will provide the opportunity to do that within a carbon-free way. And that's another area that, from a regulation standpoint, I think, Edward, you guys at the ISO in Ontario are certainly looking at, what does this mean in terms of having these kinds of hybrid resources on LDC grids. But energy storage is the heartbeat of allowing all that stuff to happen, especially on site if you're going to do it with renewables. And regulations and how it's dealt with in terms of markets are all things that need to be worked on in order to unlock all of the abilities that energy storage has on the distribution side.
Alex, Edward, anything to add to this, or?
So, yeah, Frederick, a couple things here. So, I think one of the big challenges that this spans, and we've been having a lot of conversations, certainly with our system operator colleagues across North America about this, particularly as our U.S. colleagues are going through meeting the requirements of FERC Order 2222, is this notion of coordinated use of assets at the distribution level. So I think to Jim's point, for example, if we have a lot of on-site benefits for energy storage, that maybe utilize power for, let's say, 1,000 hours a year, what happens to the other 7,000 hours of asset utilization potential for that it can provide back either to the local power system and the bulk electricity system? So if I simply just pull more assets into the wholesale market, that potentially then sets up a significant problem for the distribution system to say, are we actually coordinating the use of those assets in a meaningful way? And so I think we're at the start of a really big conversation, not just about storage, but also about the broader DER integration problem. We've been engaged very heavily actually here at Ryerson University on a number of facets of that problem. I just noted this morning, of course, the big headline out of Europe is the establishment of the new EU DSO entity. So all of the distribution system operators in Europe now have coalesced into an organization backstopped by the European Union to start coordinating on market integration between the wholesale and distribution level. We're not quite there yet in terms of level of sophistication here in North America and having that dialogue, but you can feel where the debate's headed. And we are, to their credit, our own regulator here in the province of Ontario has recently started an industry consultation about DER asset utilization here in the province of Ontario. I think that's an area really that's going to help a critical missing piece of the puzzle going forward in terms of especially distribution connected energy storage. Is, do we have not only the right market structures in place, but the right connections between different levels of the electricity system to ensure full asset utilization, or revenue stacking is the local slang term here in Ontario that gets kicked around quite a bit, but very important to investors here.
All right, thank you. I suggest the panelists, as the time is flying by, to probably look at other angle of our discussion now, and probably in the follow-up of the previous session that was on the electrification of transport. I would like to ask our panelists how the electrification of transport is a game changer for the energy storage industry.
Maybe, Fred, if I could start the conversation on this one a bit. And I'm going to link it back to what Edward was talking about. The impacts of the electrification of transport, that's really going to be seen. Obviously, the effects will be seen on the transmission system, but it has a lot to do with what the transmission system is feeding. And I think, what's going to be important for operators is to be able to observe what's happening and be able to predict the behavior of what's happening in order to know how to respond just at a very high level. Certainly, I think, if you look at decarbonization of society, I think the power generation industry was one of the first targets maybe it was lower hanging fruit, but I think if you look at the amount of carbon coming out of the transportation industry, that's going to be, and I think it already is becoming the next target. So I think we're going to see it. What's going to be very interesting is that, when you look at traditional, if you are a transmission planner and you're looking at traditional planning for reliability, and I'll define reliability at a very high level as making sure you have the right megawatts at the right time, in the right place, and in the right way to keep the lights on. Traditionally, you would say, all right, my loads are in this spot and my resources are in this spot. As you electrify transportation, that pattern has the potential to largely shift, where, what does it mean now when I plan for a system where loads change and potentially, the resources that supply those loads are changing where they're located. So if you want to think about it in terms of this as the load and generation profile might look very different in Boston and Cape Cod during a regular weekday versus the weekend, or, up in Ontario, this would be like saying Toronto and Muskoka or Wasaga Beach or, the Kawarthas would look very different potentially during a weekday than what they would look at like on the weekend. And just making sure that we're able to see that and plan for it and be prepared for that is, I think, going to be a very interesting challenge and opportunity.
If I may sort of follow on to that, I think part of the challenge and the opportunity is also simply in the increase in demand, in load. And as we electrify not only transportation, but also buildings, and you're seeing real movement towards that already here in my hometown in Cambridge, Massachusetts. The city council is debating having new construction here no longer be able to use natural gas directly, but rather to be electrified for the kinds of services that traditionally would be provided by natural gas pipeline. And I think what you're going to see is, for example, summer peaking systems move then to a winter peaking system. You're also going to see overall the demand for electricity increase significantly, which is also going to change, where we get our generation from, and then how we firm it over time. So I think those are also important parameters, all adding to the excitement. Going back to your very first question, Fred, I think that's part of the dynamic that makes this such an interesting, exciting time to really be thinking about energy storage and the value and the use it can play in the changing of these dynamics and supporting them to continue to deliver resilient, reliable power.
And Fred, if I can just put an extra little bit onto what Ramya said, I completely agree with what she said. Her being in Cambridge, Massachusetts, she's probably heard a lot about what the state governments in New England have been saying. Really, if you think about it, the power grid is the world's largest universal adapter, and you can plug in different supply sources and loads. And I think societies such as, what the states are looking at in New England are really looking to figure out how to decarbonize. And I believe they're really thinking that being able to plug in renewables and supply loads that haven't been supplied necessarily traditionally from the electricity system is really what's in their minds. And that seems to be very clear in the dialogue and even some of the evolution that we're already seeing in the plans for the system here in New England.
Yeah, and Fred, if I can just chime in on a couple of things. First of all, what we're looking at right now is electrification of transportation version 1, which basically has power coming into electric vehicles. And for the most part, except for a couple of manufacturers, they're all going, okay, hang on about this vehicle to grid stuff. We're really not sure how that's going to affect the cycle life of our batteries. So if you go on version 1, and there was mass electrification based on the current technologies of batteries only being able to receive power that's going into vehicles, then you're going to need large energy storage centers in distribution centers that can actually buffer what those charging stations are going to require based on what that distribution grid can actually provide. There's going to need to be electricity holding tanks, so that there aren't problems in terms of having to build out massive infrastructure to deal with the peak demands that could come from vehicles. On the other hand, if you go to version 2, which is now the electric vehicle manufacturers have technology in place where cycles are no longer such an issue, and there's technology already on the drawing board that'll be able to do those kinds of things. Then all of a sudden everything starts to change because you can use those assets as part of the grid. And Edward, if you think you've got amalgamation challenges now, I would imagine something like that's going to be even more exciting for both you and Alex moving forward. But it's going to play moving forward. If we're going to decarbonize, we have to electrify the transportation sector, and it in itself, just due to its magnitude, will get all of this technology to scale that will really drive its costs down, which is, again, having things going in the right direction.
Yeah, those are great points, Jim, and it's one that we've been starting to spend some time thinking about, as well as, how do you regard that new electrification load. Our annual planning outlook, again, this is very early, but we have provided some initial projections, for the next 20 years on electrified transportation here in the province of Ontario. At the ceiling end, we're looking at somewhere between 3.1 to 4.1 terawatt hours of new electric vehicle load, and potentially up to another 1.8 terawatt hours of electrified rail load, which brings a whole other interesting dimension and opportunity for energy storage as well. But I think, to Jim's point, is, do I regard that as just simply an additional load burden being added to the power system, or potentially in the future a more price elastic segment of the demand curve? And I was watching this morning's electric vehicle panel presentation with great interest. There's a lot of discussion about electric vehicles absorbing surplus base load, re-injecting at different times. But it's interesting, as they're going through that part of the discussion, that also parallels a similar conversation we have with grid-connected energy storage at the wholesale market level. And if I look at those two separate problems from a pure economic standpoint, they really should be merged into a cohesive market, right? And I think this is part of the impetus behind FERC Order 2222 and the broader DR integration. They shouldn't be two separate demand curves. Ultimately, in the future, they should be really integrated into a cohesive market where energy storage at the distribution level is in direct competition and healthy competition with assets at the wholesale market level, including wholesale market storage assets, right? That ultimately is the healthy competition space. And I'm certainly not the only one making that observation. I know MIT has, in their landmark paper on utility of the future, has been saying this for the better part of a decade now, is about the need for every asset to be able to compete with every other asset on the system. The technology's there, but it really is the regulatory and market structures are going to have to catch up with where the technology is now leading us. And so Jim, I think it's a really salient point. We have to look beyond version 1 of what's being put in front of us by the electrification wave that's happening right now, and really start to think about the next generation technologies and what that's going to mean for markets.
Good. So I think we saw a lot of potential of opportunities there. But again, as it does echo what the start of this panel has been pointing out, is a world of possibilities, but is a real shift in the way energy is used in a very dynamic way, which offer up new opportunities for technologies, but as well a real challenge from grid stability. But before we talk to grid stability, and I see on our Q&A we're having some question about that, I would like to keep the grid stability question and reliability question probably closer to the Q&A session, because I think we'll have some synergies there on the way to respond and or being able to interact with the Q&A. But I think I'd like us to talk about a subject which is very close to my heart, and I know that we're all sensitive to this. We talk about the decarbonization. It's with the purpose of the greater good of our planet and our planet's sustainability. So when we look at the accelerated demand and growth of battery energy storage, it does pose a question. Have we learned from the past, from other sources of energy, and the way we have managed these energy sources and the raw material to create these energy sources there? Are we on a trend which is sustainable for our planet? And will we see moving forward a shift in type of technology or circularity models kicking in there? I'd like to hear the panel on the field of sustainability for this industry.
So, Fred, I'll jump in.
All right, Jim.
Decarbonization is, I think, important to all of us, but it's one of the things that Ameresco is really focused on for its customers now, given that we actually start on site with load and how do they manage their carbon footprint. I think what we're seeing from the battery manufacturers, and I know, Ramya, you'll probably have some good things to say about this, but all of the manufacturers that are getting into this game now understand that their products have to have an element of carbon sensitivity to it as they're manufacturing those products. And interestingly enough, most of the tier 1 battery manufacturers now are offering systems whereby they offer an end-of-life plan for these systems, whereby they actually are interested in having those systems get returned to them at end of life so that they can recycle all of the products, the lithium, the copper, the silver, the gold, all of that mining material that goes into making those products are all recyclable, providing they're manufactured in a way that it's easy and economic to recycle it. And that seems to be a main initiative by many of these manufacturers that are on the lithium-ion side. So I think it's definitely there. It's on everyone's radar. Part of what we have to do now in terms of reporting when we build anything new, be it a building or an energy asset, is what is the carbon footprint that was actually part of that. So it's gradually making its way out of the supply chain. And I can't imagine why some of these brilliant manufacturers that are coming on board can't figure out a way to make sure that they are manufactured in a sustainable way.
So if I can jump in on that point from Jim, I completely agree with what he's saying in the sense that, answer your question in a very succinct way, I think we collectively have learned from the past. So it is no longer enough for any manufacturer, any seller of systems to say, well, we're clean because we're going to pair with renewable energy. No, our customers are demanding that the overall carbon footprint of the manufacturing process on our end is a part of that evaluation, and rightly so. And again, as Jim said, the recyclability, the end of life, the actual environmental impacts of usage while the system is in operation, all of those are now part of the evaluation process and the questions that we're getting from potential customers, and rightly so. And so we are definitely seeing that as well.
Thanks, Jim and Rami for your insight. Certainly, what I hear already is that it must start from the inception and the design process of these technology and these products. So that's certainly something which we gotta, as I said, it's close to my heart for sure, but it's very close to Schneider Electric heart. So thanks for your perspective, Alex and Edward. Any perspective from your end on the view of sustainability of this energy storage technologies entering into our space?
So just mindful of our role as a system operator, we're a technology agnostic facilitator of markets, but there is certainly tremendous potential to apply various forms of policy to price in sustainability into markets and ensure that factors in as we see in the debates in other segments of the energy sector as to what degree, for example, carbon pricing gets priced into energy supply. Are there other aspects that could factor into this? Again, that's a question for government to settle, but potentially a matter for system operators to implement as that dialogue intensifies over the coming years. I think two things that give me great hope in this area, though, Frederick. On the optimist side, first of all, if you look at the most mature part of the energy storage market, or most mature segment, which is really, you think about it, is lead acid batteries in cars, which have been around for the better part of 100 years. They have an amazing product life cycle. About, when you take an old battery out of a car, certainly here in Canada, about 99% of that gets recycled. The chemicals, the metal electrodes, even the plastic casing gets recycled. It's an incredible success story. And And I think what everyone is saying is, and what Jim touched on, there's tremendous economic value to solving the sustainability problem. If you look at the projected use of batteries, is whoever does solve these problems, there's a huge amount of money to be made. And that alone gives me hope, right? That the economics itself will drive the supply market along to sustainable approaches. So it's not just a matter of government policy, but there is a real pure economic incentive to work on that part of the problem. And that is at the end of the day probably one of the most powerful motivators for industry. So I think there is a solve for this problem. It may not be clear at the moment, but there are a lot of really bright minds working on it right now.
Thank you, Edward. Yeah, Alex, yeah.
Yep, and so Edward, I think, summarized very well the position I would also share from the ISO perspective as far as technology neutral and reflecting what people determine pricing is appropriately in the markets. Just to add to that, I think one thing we need to be careful is, I know battery storage is what's been the focus right now when it comes to energy storage, but energy storage is not just battery storage. And so it'd be interesting to see what other technologies come along, and some technologies that have been there for some time. So for example, New England has had actually large scale energy storage for years through, we have 1,800 megawatts worth of pump storage split across 2 facilities, right? So the concepts of large scale energy storage have been around, but I personally, I look forward to see what happens in the future as far as technologies evolve in order to be able to find energy storage solutions that are economical and sustainable and beneficial to the overall energy landscape.
Thank you, Alex. Yeah, so let's move again, and I'm conscious of time. We have 14 minutes to go, and I'd like to being able to answer some of the questions that have been coming up on the Q&A. But I think several of you have touched, new field of technologies and so on, and I would like to hear from the panelists on what are the field of studies that academics or R&D centers should be looking at now with this world of possibilities, but as well the world of challenges, which for many startups that could be great opportunity to reflect on. So what is your view on the field to be considered in this space?
So I can start an answer on that. From our perspective, the single biggest barrier to new technologies, which folks are talking about, in particular on the long duration side. So when I talk about duration, I'm always talking about discharge duration or generation duration, meaning how long can you generate in a storage facility. And we see extremely good models of how durations of 2, 4, maybe 6 hours can participate in the market and are compensated for the values they provide. We're increasingly seeing evidence that the market is starting to demand longer durations, 10 hours, maybe even longer, in a variety of places. But the single biggest barrier in our view is the lack of consensus on how to value long duration. What are the exact value streams? How do you stack them? And how do they then fit into market design? And so, in our view, a concerted effort to really get to that question would really provide a huge amount of benefit in a technology neutral way, and really catalyze new innovation in this field.
And Fred, I'll take a little different approach from what Ramya has done, and maybe talk about it from the standpoint of how Canada can get involved in this in the energy storage sector moving forward. Someone needs to develop a business plan and the research and technology behind it that actually legitimizes having Canada become a producer of lithium-ion batteries right here, as opposed to shipping our minerals as we have done in previous years. If you want to look at this, what have we learned from the past? Our value as a country has come from basically shipping our raw materials to other countries where they can then manufacture it and take those products to market. What we have now at the dawn of this energy storage or new energy era is an opportunity for Canada to switch gears on that mode and instead to find how can we take the raw materials that we have now to basically go through the entire manufacturing chain and take those products to market and market the products to the rest of the world. But that seems to be difficult for us to do here in Canada, especially on new technologies. We have all of the raw materials we need. We certainly have all of the talent we need to put it together. We need a concerted effort, I think, to figure out how that can happen. And the Canadian government is in a position right now where they have significant funding available for companies that want to go in that direction. So if there are smart young people at Ryerson or who want to look at doing something like this moving forward, this is the time to figure that out. And there needs to be some R&D to help get that done.
Yeah, thank you, Jim, for your perspective on that. Certainly, it does create some echo, yes, on the opportunity we have in Canada with our raw material. Alex and Edward, perspective that you have on the innovative space ahead that research should be focusing on?
So, Frederick, first of all, some of the areas that we've been focusing our research here at the ISO on has, perhaps a bit of a different angle is particularly on the aspects of operability and reliability of energy storage facilities as they get integrated into the bulk power system. Make sure that they actually contribute to mission number one of keeping the lights on. We've certainly over the past few years we've been conducting field research studies in the area of fast frequency regulation from energy storage. Ramya touched on synthetic inertia, which is a little bit further to the edge of the radar screen, but we do have a storage facility here in Ontario that's just begun providing us with field research data on synthetic inertia service, and we'll be having more to say about that in the coming months. And certainly as renewable penetration increases, we need to start thinking about our options for integration. Another topic that's coming onto our radar screen as we talk to our fellow system operators, and maybe Alex may have a little bit more to say about it, is the fast ramping capabilities of energy storage. As I think we're all learning, is a double-edged sword. So on one hand, it's extremely helpful to have flexible, fast-acting resources. But what some system operators are now discovering with very high penetration levels of storage is that sudden ramping capability is actually potentially is sometimes too much. It is a classic example of careful what you wish for. If you get too much flexibility on the system, rapid ramping actually can lead to system disturbances and intra-dispatch problems as well. So that's another area we'd like to delve into in the coming years, is make sure that before we get to large penetrations of storage here in Ontario, we're well armed and equipped to be able to cope with those type of operability issues. And then the other aspect that's also coming onto our radar screen is AI and automation of storage facilities. We're finding a lot of storage participants are early adopters of AI technology in terms of interacting with markets and operating their facilities. And this is an area we're also very keen to get our arms around that and how that's affecting the broader operations of wholesale markets as well.
Thank you, Edward.
Yeah, so I think that's I think we've touched on a lot of points here. Maybe I'll try to step back and put things into bigger buckets, and I'm going to attempt it because I think there's problems that we already have the ability to study out. So some of the problems of traditional reliability, such as frequency response and inertia, the ability for stuff to operate at lower short circuit levels as more of these technologies come online, and traditional power plants that provide a lot of short circuit capability leave the system. Those are problems that are on our minds and need to be worked through, but I think there's a lot of traditional tools to study them. I think some of the ones that are a little more interesting and new, Ramya has touched on this a few times now. It's as societal priorities change, how do you figure out what's a value and what's a cost, and then figure out how to put that into quantities that then could be translated into markets? I think that's an interesting area. I think one other area that was interesting related to reliability, and Edward talked a lot about the reliability angle, is to step back and say, traditionally reliability, when it comes to power system planning and operation, has looked at certain periods of most concern, like summer peaks, winter peaks, depending on your systems. And operability and observability have been very easy to achieve. I think the operability and observability of a lot of the small scale stuff that's coming on the lower voltage systems is going to be an interesting challenge to understand. And I think, Edward, you touched on that a little bit. And I think one of the other ones that's going to be interesting, and we're already asking ourselves questions, is when it comes to reliability, what really do we need to be looking at now? So for an example, traditionally, you would have seen a summer peak in a system like ours in New England, 2 or 3 o'clock in the afternoon. Last Monday, we had a high of, and I still get my weather in Celsius, so we had a high of 36 degrees C, 39 with the heat index. And it was interesting to see that we didn't peak in the system until about 6 o'clock. So, things are changing, and I think we need to just make sure we ask ourselves, what's critical when it comes to things like reliability.
Thank you, Alex. I suggest now we have 5 minutes before the end of the panel, and I'd like us to answer some of the questions that have been asked on the Q&A, and already thanking people that have put their question there, so for us to react on. And I'd like, it does talk, Alex, to the point you just mentioned, about grid system reliability, but on the view of the role of software in ensuring the system reliability. So how do you see the future with the impact of the software component in ensuring that grid reliability here? So maybe, Alex, if you can jump in on that one.
Yeah, that's a very good question. Where to start? If you think about it, just if you looked at how a study was done and for the system 20 years ago, you could run 2 or 3 simulations, and you had a stack of punch cards that hopefully you didn't drop on the way to the machine, and so on. And so you had to think very carefully about what specific scenarios to study, but that was okay because the way the system was set up, it was simplified. I'm not sure that's the case going forward. I know at ISO New England, we've leveraged cloud computing already to be able to run hundreds of simulations in a short period of time, something that even 5 or 6 years ago was not imaginable. So I think there's the ability to crunch through a lot of data, a lot of simulations. I think that software is going to continue to impact that. I think one of the other areas there needs to be coordination with software and other aspects is that issue of observability and controllability, being able to be situationally aware of what's happening and being able to figure out how to optimize things altogether. I also think there's going to be an evolution on forecasting. It's already happening, and obviously software is going to impact those areas. So just off the top of my head, that's some of the main areas I see the evolutions happening when it comes to software. But just with the evolution, I'm sure there's other areas that we haven't even imagined yet where software is going to play a critical role.
Yeah, thank you, Alex. Thanks for your perspective. Other panelists want to react to this field of technology and the perspective it offers?
Well, that's I think it's certainly an area of high interest for us as well, not only in the context of energy storage, but also the integration of mass scale, small scale assets at the distribution level, and how that rolls up into DER aggregations, participation in wholesale markets. I'd say a theme that runs through all of that is, to me, and I would even argue it's even more important than the software, is the interoperability standards that that software adheres to. It's often the overlooked topic because it's sometimes not the most exciting topic for policymakers to look at or provides immediate benefit, but it is the one that prevents the creation of artificial monopolies and ensuring that you actually have open access and competition at all levels of the system. So if we're ever going to realize that long-term vision that MIT put out there, where all assets compete against all other assets, what underpins that is the standards that software actually adheres to. And so again, the organization I often cite is the U.S. National Institute of Standards and Technologies, which has the Smart Grid catalog of open standards. I think they've laid at the feet of industry and market facilitators is to say, look, here is the rough blueprint of what needs to be put in place to make sure that you can realize both not only a secure system for these things to operate in, but also one that maximizes competition as well. And I guess I'm not being the policymaker. To me, it is the topic that has been somewhat overlooked over the past decade and is going to become of critical importance going forward.
Thank you, Edward. Yeah, so hey, again, conscious of time, we have 1 minute-ish, but I think there was one which was probably passing the puck to you, Rami, on the, is there any, and I think you did touch that, but any storage technology on the horizon which will be able to provide more power than few hours a day? So I think you did touch that, but I think it's probably passed directly to you. So
I'll try to keep it brief in recognition of time, and at the risk of sounding extremely self-serving, I will say absolutely. And Malta is, my company is developing one of those technologies. And we certainly expect to be able to offer daily or weekly cycles. So call it anywhere from 8 to 200 hours. All that being said about Malta, what I say is this is a very fertile field, and there are a number of companies that are really focused on long duration technologies that and segmenting the market in different ways, right? Focusing on different sizing so that the customer base would be different depending on whether you're really offering it on the commercial industrial scale or the bulk power scale, segmenting on duration, whether the idea and the economics are really based on a daily cycle, a weekly cycle, or a seasonal cycle. And what I'd say is that market segmentation has significant implications ultimately for cost. And the idea of different technologies segmenting the market really also means that they're going to have to offer their competitive offering at different costs depending on the cycling capability of that technology. So short answer, yes, really exciting field. And there's a lot of fertile work on this ongoing right now.
Thank you, Rami. And I think now it's time for us to wrap up, but I'd like to wrap up the session by saying a few things here. I think we heard great insight from our panelists, and I'm very thankful for each and one of you for your contribution today. And it does trigger an image here. I think since electricity was invented, that was the dream of being able to store energy. And what we heard today is the time is now. We are really at a turning point in the industry as we are decarbonizing our societies, our economies. We're adding new renewable energy storage, and we heard it's not only battery per se energy storage. There is different source of storage of energy that will need to complement our grid and to create the energy flexibility that I think every panelist did touch one way or the other. Energy flexibility at the grid level, but also closer to the demand to offer this field of capacity to being able to supply the energy when it is needed. We heard many challenges on making that happen, but I think what we heard is that there is a side of a great sense of opportunity and hope that the energy storage will really help to change the energy landscape around the world, but as well in Canada, where there is a great opportunity for our industry, our research centers as well, to play a role in there in the way we optimize and regulate our energy sector. So really big thanks to our 4 panelists today. Big thanks to Ryerson and Leading the Charge conference to giving us the opportunity to share these great insights with everyone. So I wish you all a great day and enjoy the rest of the conference. Thank you all.
Thank you, everyone.
Thank you, Frederick. Thanks, everyone.
Thank you.